In this chapter, I make a slight error when I talk. I've already recorded the video. Make sure you understand that the formula for this is p hat plus or minus, we often say z star. This is our confidence level right here. And then we'd use the square root of p hat times q hat over n. In the chapter video you're about to watch, I sometimes say p and q up here. This is p hat and q hat. This is for sample proportions because they are going to make confidence intervals for the true proportion. P is the true proportion where p hat is the sample proportion. You can see down here how to work these right here by plugging in. In this problem, the sample size was 200 and the proportion was 76%. You'll see in this chapter here how we would find x for this, but afterwards come back and see if you can figure out how I obtained the value of 152 would be x. That's actually what x is for this problem. See if you can go back and solve this and figure out how this was worked right here and why we're using 1.96. What confidence interval is this? If you can answer those questions, you're doing pretty well. So without further ado, here's the chapter video. For these problems, we will be building confidence intervals. Now the first part wants you to interpret a confidence interval. So when we look at a confidence interval, it has two parts. We have the center plus or minus a margin of error. Now interpreting it requires three things to say. First, start with your confidence level. I am 95% confident. Then, to what you're actually talking about. That the true proportion of orders that arrive within 3 days that were made on the internet, and finally give the interval, is contained in the interval, and if we're going plus or minus 4%, it would be 82 to 90%. So remember, first part, your confidence level. Second part, make sure you give what you're talking about. Third part, give the interval. And if you look at what follows that right here, one can be 95% confident that the true population percentage of orders placed on the internet that will arrive within 3 days is contained, I will say it that, is contained in the interval 82 to 90%. Excellent. Going on here to this problem, now get your TI calculator out. I can't reinforce that enough. The TI calculator is a huge help. It'll make these problems very, very easy. So with the TI calculator out, here is what you will do. You will turn it on first, and you will go to Stat, Tests, and you will scroll down to number A, 1 prop z interval. From here, you will put in x, which is your number of successes, 4,610, and then your sample size, 100,000. Next, you will need to give your confidence level of 90%. You can hit calculate, and the answer is instantaneously given to you. Now, here's the problem we run into as I type in the answer. A lot of people won't realize when to use which things on the calculator. It helps to look at the formulas and know how they work and know how to use the formulas as a backup. Now, when we do the formula, we can see a problem over here that I worked on just like this. What we have are three parts. We have the center, the confidence level, and the standard deviation. In this problem that I worked right here, the center would be 0.05034. There's a different problem that I worked on where it asked me n, little n, don't change that for me, computer, equals 100,000, and x equals 5,034. So with n of 100,000 and x of 5,034, we would get the center of about 5%. It wanted a 90% confidence interval, and that might be the hardest thing to find. You can use your David M. Lane applet to get that, because if we ask for a 90% confidence interval on the standard normal, we will get 1.6449, or 1.645, but I carried it out another decimal place. So with this in mind, this is what creates a 90% confidence interval because it's the central 90% of the interval. That is why we use this number. Going back here, we need a standard deviation because this relates it to the distribution. Without a standard deviation for the distribution, we'd be using this 0, 1 model right here, We need the actual standard deviation. We're basically plotting it onto this normal model. We take the standard deviation, put it on there, and we put the center at where the center is, and we've figured out the central 90%. That's what we're doing. So make sure to go over this and know how to use this formula. Down here I've solved the standard deviation. You can see it's very, very tiny. So use these formulas here and make sure you practice with them. The formula is p hat plus or minus z star p times q over n square root. That is your formula. If you want to really master this chapter, and I implore you to do this, I beg of you, do it on your calculator and do it by hand. Know what to put in where, because the calculator turns out to be magic for a lot of people, and they don't know what they're doing. Is 4.4 plausible? And we're going to say no here because it's not in the interval. With this problem, the same rules apply. And this time it actually gives you p hat. So it actually gives you it. So go to your calculator, hit stat, tests, and scroll down to number A. We need to put in, and this is where people get confused, it wants x, which is number of successes. So when it asks for x, we have to do right here 20% of 2,300. You can actually type that into your calculator. You can type in 0.20, or excuse me, 0.20 times 2,300, and you will get 460. Now, if you get a number that isn't a whole number, you'll need to either round up or round down because the calculator can't handle a number that is not a whole number. Next, we need to put in n. And finally, we need to put in our confidence level, 0.98. Now, we can do this by hand. Let's go ahead and look at this by hand. Doing this by hand right here, we can substitute in 0.20. And next, we need to put in the confidence level here. I think this one's 2.3236, I think. Let's put in a 98% confidence interval. Let's see what we get. Yep, that's what it is. I think it's 2.32, no, it's 2.3237. I was close. 2.32, was it 37? 2.327. There we go, that's the right answer. Because that's our confidence level related to the 98% confidence interval. Next, we need to put in P times Q over N, which in this case was, I think it was, let me see here, 2,300, and square root it. So everything would turn out a little bit differently this time, and it looks here, let me change this up for this problem. My mouse is acting weird again. For this problem, we have n equals 2,300, and we have x equals 460, and that is not given to you. You have to find that. So let's go ahead and create our interval right here. Let's solve the math. Make sure to solve it both ways. Our interval, and it wants it in decimal form, is right here. Remember, to master this, solve it both ways. Very important. So to explain this, remember how we interpret. I am 95% confident that the true proportion of children who are deficient in vitamin D is contained in the interval. There we go. So right here, we are 98% confident that the interval contains, we are 98% confident the interval contains the true proportion of children deficient in vitamin D. It's not adults, it's just children. So, explain what 98% confidence means. About 98% of random samples of size 2,300 will produce confidence intervals that contain the true proportion. I don't like that includes population proportion. That's about the same thing. They kind of use them interchangeably, and I do too, but that's the right answer right there. So with this in mind, we're looking at a very similar problem again. Make sure to solve it both ways. It wants a 99% confidence interval, and I believe a 99% confidence interval is 2.5758. It's going to say 5756. I know it. There it goes. It rounds every time. So what we're doing is we're covering the inner 99%, but we need P and Q and N. Well, N is 1015. That is the number sampled. We have 11% was the P hat. So we can actually solve right here. Let's go back and get our numbers again. 1015 and 11%. Let's go to Word. 11% is our P hat. And we need to put an 11 here. And we need to put in Q here. And then 1015. Next, we can do it on the calculator. And I beg of you to solve these out because a lot of people will get confused. If you have 11% right here, which I messed up and meant to put 11 right there. If you have 11% right here as your x, you can type in this into the calculator, straight into there, and that'll solve for what x is. But like I said, if you get a decimal place, the calculator will reject that because it's like saying there's 1.2 men in the room. It doesn't make sense. So let's go ahead and solve this for x. And it gives me 1011.65. I have to round it to 1112, excuse me. So it gave me a decimal and I had to round it to 112. So now I'm going to type in n, which is 1015, and my confidence level, which is 99. I calculate, and it gives me the answer, but make sure to solve this. Practice up on solving these, know how to identify p hat, q hat, and n, and know when to plug it in. And we will often give you the z-score on the test, because we wouldn't expect you to know what a 99% confidence interval z-score is. Rounding right here, we should get this answer right here. There we go. So once again, practice up with the equations, know how to use a confidence interval. Very, very important. Solve them both ways. Know how to identify how to make the confidence interval from what is given to you. If they obtain this from a sample, it is p hat. That is the difference between p hat and p. In your previous chapter, chapter 18, it talked about p, where it was a known proportion. This is p hat, where it's from a sample. We make confidence intervals from samples. That's very important, because if we know the true proportion, well, we know it. If we don't know it, we want to estimate it with a confidence interval from a sample. Good luck.